Assalamualaikum and hi to everyone. My name is Ahmad Mambi Ahmad Niza, and I'm here today as a representative of Group 6 to present our topic titled Material for Enhancing Safety and Efficiency. So before we begin, I'd like to introduce the members of our team. The first one is Farid Ikman bin Nizam, second one is Muhammad Azib bin Syahidin, the third one is Wan Sofia Anas binti Shahruddin, and last but not least, there's me, Ahmad Mambi Ahmad Niza. And as for me, I'll begin by providing the introduction to our topic and sharing details about the material we have chosen, which is the aluminium magnesium silicon alloy, or ALMGSI, from the 6000 series of aluminium alloys. So let's get started. Now, let's start with the introduction. Advanced technological developments are required to provide maximum performance, safety, and efficiency due to the rapid growth of autonomous vehicle technology. The selection and application of the appropriate materials is one of the most important factors to achieve this objective. Components for autonomous vehicle must be a combination of strength, lightweight properties, and durability. So the objective of this study is to determine whether the material is suitable to apply in autonomous vehicle through analyzing aluminium alloys in terms of natural structure, important mechanical and physical properties, microscopic characteristics, processing techniques, and design limitations. The second one is to give better understanding of how aluminium alloy are engineered to meet the high requirements of modern vehicle systems. And next we will move on to the details on the type of materials. For this study, we have chosen to focus on aluminium alloys, specifically the ALMGSI series, which falls under the 6000 series of aluminium alloys, and I will explain about their relevance in autonomous vehicle applications. The 6000 series aluminium alloys are composed mainly of aluminium with magnesium and silicon as the key alloying elements. These elements combine to form magnesium silicide Mg2Si, which significantly improve the strength of the alloy after heat treatment. One of the most important reasons for choosing this material is its excellent strength to weight ratio. This property makes it ideal for reducing the overall weights of automotive components without compromising structural integrity. In the context of autonomous vehicles, this weight reduction plays a critical role in enhancing efficiency, handling, and energy performance. By reducing the weight of key components such as body panels, chassis parts, and crash structures, manufacturers can achieve a significant decrease in fuel consumption or energy usage, especially in electric vehicles. This in turn helps in lowering greenhouse gas emissions, contributing to a more sustainable transportation system. So in summary, ALMGSI aluminium alloys from the 6000 series offers a combination of lightweight performance, strength, and environmental benefits, making them a highly effective choice for the future of autonomous vehicle. That is all from me. Next, I'll pass the baton to Muhammad Azib bin Syahidin to present the physical properties of the material.
Thank you, Ahmad Aiman. My name is Muhammad Azib bin Syahidin, and I'm going to talk about the physical properties of aluminium, magnesium, and silicon alloy. The aluminium alloy has a good physical properties. For an example, the density has a typical value of 2.7 gram per cm cube, helps to reduce the mass because of a lightweight structure. Next, the melting point is range around 555 to 650 degrees Celsius, and it is suitable for manufacturing process such as mold casting and welding. The thermal conductivity for the aluminium alloy range around 150 to 200, and it is good for heat dissipation that can protect electronic systems and battery packs. Next, the specific heat capacity of the aluminium alloy is around 0.9 joule per gram kilo, and it helps to absorb and withstand heat that helps to enhance performance. And last but not least, the reflectivity for the aluminium alloy is around 80 to 90%, and it helps to reduce heat absorption from solar radiation and good to maintain interior temperature.
To briefly explain the key properties of the material we are focusing on and why they matter. First, it has a yield strength between 150 to 350 megapascal, which means it can handle impacts or loads without permanently bending. Its tensile strength goes up to 400 megapascals, so it's strong enough to carry heavy or dynamic loads. The elongation at break is around 10 to 20%, giving it good ductility. This helps the material absorb energy, for example during crashes. Meanwhile, the Young's modulus is about 69 gigapascal, so it's stiff enough for structural use, but not too brittle. Its hardness is between 60 to 90, offering decent protection against wear and abrasion. Plus, it's quite lightweight with a density of just 2.7 grams per cubic centimeter, which helps reduce the weight of verticals and boost efficiency. Lastly, it has high corrosion resistance, meaning it lasts longer, even in harsh environments. Let me now briefly talk about the microstructure of aluminium, magnesium, and silicon alloys. The main part of the alloy is the aluminium matrix, also known as the alpha phase. This gives the material its lightweight nature and good flexibility. Next, we have magnesium silicon precipitates. These tiny particles help strengthen the material through a process called edge hardening, which improves its overall hardness and strength over time. Then there's the grain structure, which is carefully controlled using heat treatment and mechanical processes. This balance is important to achieve both strength and toughness. Lastly, there are secondary phases, especially those with iron. These ferrum-rich intermetallics often appear as needle-like or plate-like shapes. Although they are usually present in small amounts, we try to reduce them as much as possible because they can lower the ductility of the material. So overall, the microstructure is carefully designed to give a combination of lightness, strength, and also the durability.
The aluminium alloy will undergo few manufacturing processes. Firstly, it will undergo extrusions. The metal will force through a die to create long constant cross-section profiles. Next, it will undergo rolling processes. In this stage, the aluminium alloy will be rolled to produce sheets and plates. Lastly, it will undergo stamping or press forming. The sheets from the rolling process will be cut and formed into desired shapes using presses and die. For the applications, there are few parts of aluminium that are utilized in automotive applications. For first part, it will be utilized at body panels, which is at hoods, doors, trunk lids, fenders, floor pans, pillars. Next, it will also be used at chassis and structural components such as subframes, suspension arm, bumper beams, axle components, and frame rails. Lastly, the aluminium alloy will also be utilized at radiators, condensers, intercoolers, and also battery cooling plates for electric vehicles. To optimize aluminium alloys for automotive applications, future development should focus on creating next-generation alloy compositions that maximize and enhance strength for mobility balance, allowing the production of complex and strong lightweight structures with improved capability. Simultaneously, efforts are required to optimize advanced joining technologies, including improved friction stir welding to ensure seamless and durable bonding of aluminium alloy to reduce strength loss in heat-affected zones and enhancing overall structural integrity. Moreover, innovations in durable and eco-friendly surface treatments are essential to enhance corrosion and wear resistance, increasing components' longevity and preserving quality under extreme automotive conditions.
Thank you, Farid. As a conclusion, choosing the right material is important for safety, efficiency, and durability. ALMGSI aluminum alloy is recommended for its excellent properties as it offers a good balance of strength, corrosion resistance, and lightweight. That's all from us. Thank you.
What was that?